Hey guys, this is Eggy with the Math Egghead program. I wanted to re-record this video because I saw that the audio was a little wacky. So just to reiterate, this video is going to be dealing with balancing chemical equations. One of my lovely followers named Joanne went ahead and requested this video and this particular problem. So I wanted to go ahead and assist you guys. Now, the question originally was, do we need to do the trial and error process every time we're dealing with balancing chemical equations? The answer is, for a beginner, yes, you do. Because when dealing with chemical equations, you do need to follow 3 rules. The first rule is, when you're dealing with chemical equations, you have to see that the reactant and the product obviously is uneven. So you look at the coefficients and you look at the subscript. You never change the subscript, you always change the coefficients. Second of all, when dealing with balancing chemical equations, you do have to look at polyatomics. Now, polyatomics can be a little tricky here because when dealing with polyatomics, usually we like to think of it as their own personal or single entity. But in this particular problem, as you can see here for the nitrate was not dealt with as a polyatomic. It was actually dealt with individually, meaning that nitrogen, hydrogen, oxygen, copper were all dealt separately. So let me go ahead and show you what I mean by that. Let me just highlight a few key points for you here. Let me go ahead and highlight some key points here. So as I stated before, this particular polyatomic, I initially would have gone ahead and consider it its own entity because it did not bond with any other atoms or elements in this particular equation. But as we can see going further into the problem, it does have to be dealt with separately. Okay, and also let's go ahead and I will highlight the subscripts. Now, I'm putting the subscripts in yellow because I do want to indicate that when dealing with the chemical equations, you never change the subscripts. That's very important because usually, automatically, we will go ahead and think to ourselves, okay, if we multiply 2 or 3, we will actually get the number that we're looking for. But that's actually not correct. So what we're only changing are the spaces in the front, which are where the coefficients would go. So let me just go ahead and show you real quick with the pink highlight in front of every molecule. This is where your coefficient would go. Now, as I stated before, the polyatomic here, as you can see, there's a parentheses on the product side, but there isn't a parentheses where the nitric acid is. So that's a good indicator that, number one, the polyatomic is not something that you should go ahead and consider its own entity. And number two, every atom should be considered separate, meaning hydrogen, nitrogen, and oxygen. Now, it would be different if, for example, if the nitrogen would have paired up with copper and then oxygen would have paired up with hydrogen, then those are 2 different molecules. So that's another indicator that the polyatomic that maybe you originally dealt with has now bonded with a different element or atom to make a whole different molecule. So you have to be very attentive to that as well. And also, when dealing with listing your elements, go ahead and always leave hydrogen and oxygen for last because those 2 elements tend to always bond with other different atoms. They're more flexible, so usually they can get a little tricky when you're dealing with balancing the equation. I'm going to go ahead and highlight that. And let me show you now how to balance properly this chemical equation by the trial and error process. Now let's get to the main course of this actual video here. So after you've gone ahead, write out your chemical equation problem, highlight your subscripts, list the atoms or elements that you are dealing with: copper, nitrogen, hydrogen, oxygen, all in order. So if copper is the first one that you started with on the left, that'll be the first one that you start off on the right. Now remember what I said before, never change the subscripts. Hydrogen and oxygen usually are dealt with last, and check to see where your parentheses are. Let's start listing all of our atoms here. So we know that we have, on our reactant side, we have 1 copper, 1 nitrogen, 1 hydrogen, and 3 oxygens. Remember, that subscript 3 only belongs to oxygen. Now, on the right side, our product, it's 1 copper. Now, with nitrogen, you see that this 2 belongs to oxygen and nitrogen. Remember, that parentheses is a big deal. Now, when you see a parentheses, that means that this is the whole thing. This is the whole sandwich. In order for the subscript to really get exactly what it's coming for, you need to deal with everything that's inside of the parentheses. So that subscript belongs to oxygen and nitrogen. But as you can see here on the left side where the reactant was, that 3 only belonged to oxygen. So we have here 2 nitrogens and then 1 nitrogen. So we have 3 altogether. Hydrogen, we have 2. And oxygen, let's start counting. We have 6 because it's 3 times 2. That's subscript 2 on the nitrogen dioxide is 2. And then we only have 1 oxygen in H2O. After counting all of our atoms correctly, now we are going to start to compare the left to the right. Now, as you can see, copper is already balanced, 1 to 1. Now, remember what I stated before. Usually, we would go ahead and try to balance nitrogen and then leave oxygen and hydrogen for last. But as you can see here, hydrogen is a smaller even number. We like to deal with the even numbers because when you're starting to deal with an odd number, chances are the coefficient is going to be a decimal. And we do not want decimals as our coefficient. So as you can see here, 1.5, 2.5, for example, those would be coefficients that we would need to go ahead and multiply the entire equation by 2 in order for our coefficients to be an even or a whole number. Now, instead of dealing with nitrogen next, I am personally going to go ahead and start balancing hydrogen. Now, I see that hydrogen on the product side has 2, and hydrogen on the left side, on the reactant side, only has 1. So let me change this coefficient to 2. And now that's going to change my entire equation. The next thing we are going to do, once I went ahead and changed that coefficient on the nitric acid, that changed everything. So now that gives me 2 hydrogens, 2 nitrogens, and 6 oxygens. As you can see, the 2 coefficient belongs to everything in that molecule. You multiply straight ahead. But now I have to compare my product to my reactant side again. So I can see that copper balances out, and I see that hydrogen balances out, but my nitrogen and my oxygen are not balancing out. Now, going forward, I have to see what is easier to deal with. Should I try to balance nitrogen or should I try to balance oxygen? So comparing the two, I see that my nitrogen is not balanced and my oxygen is not balanced. Now, whether you divide 3 divided into 2 or 9 divided into 6, you do get 1.5. As you can see, oxygen is in 3 different molecules: copper 2 nitrate, nitrogen dioxide, and water. So it would not be as simple as you thought to balance the oxygen. I want to do something that is very simple. So it would be easier to go ahead and try to balance nitrogen. Remember, you want to deal either with the numbers that are smaller or the numbers that are even. Now, in this case, I wanted to deal with the numbers that were smaller. And I see that the coefficient here on the product side is 2. And I don't want a 1.5. And if I divide anything, it's going to be 2 plus the 1.5 coefficient. It's going to give me 3.5. I don't want that. So in order to simplify things, let me just change this number entirely and let me just double it. It never hurts to double a number, but as long as it's a whole number. So it's 2, 4, 6, 8 is fine. So let me go ahead and change this 4 coefficient. And now I see that it's going to change my entire molecule. So now it's going to be 4 hydrogen, 4 nitrogen, and 12 oxygens. Remember, that 3 subscript only belongs to oxygen. Now, let me go ahead and look again. How can I compare the left and the right? Copper is still fine. Nitrogen, hydrogen, and oxygen are not balanced. So once you go ahead and pause the video, take a look. What would be easier to balance? Would it be easier to balance the 3 and the 4 nitrogen, the 2 and the 4 hydrogen, or the 9 and the 12? To me, it would be easier to go ahead and balance my hydrogen because 2 goes to 4 very easily. So in order for me to have 4 hydrogens on the product side, on the reactant side, I would have to change the coefficient on the product side, which is on the right side. So 2 times 2 equals 4. So let me just go ahead and add this coefficient to the hydrogen. And this changes my molecules again. Now I have to recount my oxygens. Let me go ahead and delete all of this so that we can start with a clean slate. So we have 6 oxygens. Then we have 2 oxygens. And now we have another 2 oxygens. So now the hydrogens are balanced. Let's start comparing again. I have a 4 and a 3 and a 12 and a 2. A 12 and a 10. What would be easier to balance? Well, I see that nitrogen is not balanced. And when I'm looking at the product side, I see that nitrogen is nitrogen dioxide and then copper 2 nitrate. Well, I don't want to touch anything that's going to start making my other atoms or my other molecules unbalanced. You have to start thinking process of elimination. If I go ahead and start touching the hydrogen on the water side, then that's going to change my hydrogen. If I start touching the nitrogen on the the copper 2 nitrate, it's going to change my copper. So it would just be easy for me to touch the nitrogen dioxide because I know my nitrogen and my oxygen are not balanced here. So now that we all made the executive decision of not touching the copper 2 nitrate and the H2O water molecule, because we already see that the other elements like copper and hydrogen are balanced, then let's go ahead and decide to change the coefficient where nitrogen dioxide is, because we know that these 2 atoms are not balanced. So either way, we have to go ahead and balance. However you want to go ahead and proceed. Now, we do need to go ahead and fix the nitrogen. Now, nitrogen here, there's 2 nitrogens on the first molecule, the copper 2 nitrate. There's 2 nitrogens here on the nitrogen dioxide. So that gives me 4. So now my nitrogens are balanced because I added 2 to the coefficient here. Let me go ahead and change everything in the oxygen. Let me recount this. And it's always good to just recount. It's okay. Don't be in a rush. Professors know that this particular redox chemical balance equation is not something that a beginner can automatically do within 5, 10, even 15 minutes. It does take a process of elimination. And remember, you are being taught specific rules, so it's okay to go a different route, just to go and find your answer. Trust your process here. So since I changed that coefficient, let me go ahead. I feel very confident that I balanced this equation. So let me just go ahead and clear everything out and show you guys exactly how many elements and atoms we have, within every molecule. And then we can see if everything is balanced correctly. So here I know that I have 1 copper. Here I have 4 nitrogen. I will have 4 hydrogens, and I will have 12 oxygens on the reactant side. And on the product side, I will have here 1 copper, 4 nitrogens, 4 hydrogens, and 12 oxygens. Don't forget to add them separately. Don't just visually see it. Write everything out. I had to clear everything out because it's always good to deal with something clear. Let's finish counting up the products. So I have 1 copper. Here I had to count my nitrogens again. So now I see that we have 2 nitrogens. Again, another 2 nitrogens. So that's 4 nitrogens. And hydrogen, I have 4. And oxygen, I have 12. So now my chemical is balanced. I hope this video was very helpful to you guys. Shout out to Joanne for requesting it, and I'll see you guys on the next one. Let's talk giveaway, guys. Now, the current giveaway on my channel is for the 12-inch 64GB Apple iPad Pro. Now, what you would need to do, you can enter 3 ways. Go ahead to my YouTube, my Instagram, or my Patreon page. Go ahead and click the subscribe or follow button. Leave me a comment on any of the videos or pictures that you see. Go ahead and let me know your name. Are you in school? Do you work? And what's your dream? Are you looking to become a doctor, a lawyer, a singer, a biologist? I've had so many beautiful comments letting me know their dreams. So I would like to know your dreams. Now remember, if you do share the post, you do have to tag me so that I can see exactly what you're sharing. I hope the videos that have been posted up so far have been very helpful to you guys. And remember, the giveaway does end February 1st. I will announce the winner on the next video posted. And good luck to everyone.